5-minute p-values. Let's go. Let's draw a continent and an island. Let's give them some color. And let's call the continent Population Land and the island Sample Island. In between is the inferential sea, which is very dangerous to cross. Let's populate Population Land. And let's sample from Population Land. And bring study participants over to Sample Island. On Sample Island, we could randomly allocate them to groups and do an experimental study, or we could observe naturally occurring groups and perform an observational study. Whatever we do, we will probably perform some sort of statistical procedure and calculate a p-value. Let's say we calculate a p-value of 0.02. We compare the p-value to alpha, which is usually, but not always, 0.05, and in this case, p is less than alpha. Therefore, we reject the null hypothesis. And if over in population land the null is false, then we have not committed an error. Yay! Let's say we calculate a p-value of 0.02 again, and we reject the null hypothesis. But in this case, over in population land, the null hypothesis is true. We have committed a type 1 error. We have rejected the null when it is true. In clinical terms, it can be considered a false finding or false positive. The p-value is the probability of committing a type 1 error, rejecting the null when it is true. Let's say instead that we calculate a p-value of 0.15. P is now greater than alpha. So we accept the null. And if over in population land the null is true, we have not committed an error. Yay! But let's say we calculate a p-value of 0.15. We accept the null again. But over in population land, the null is false. We have now committed a type 2 error. A type 2 error is accepting the null when it is false. In clinical terms, it can be thought of as a false negative or a missed finding. Returning to our p-value of 0.15, if we accept the null hypothesis, we have to ask, does this mean that the null is actually true? It does not. It only means that we failed to find enough evidence to reject the null hypothesis. Remember that the null hypothesis refers to what's going on over in population land. And we will never actually know what's going on over there. Another factor to consider is power. Let's say p equals 0.15. We accept the null, but what if power, which is 1 minus beta, equals 0.40? Well, what does that mean? That means that we only would have had a 40% chance of rejecting the null hypothesis if it was false. In other words, we only would have had a 40% chance of avoiding a type 2 error. By now, something should be striking you as troublesome. We're on Sample Island, and we have no clue what is going on over in population land. All we can do is use the data from our participants to make a guess. This guess could be correct or incorrect, but we will never know. That is a problem that is related to some very fundamental misconceptions about p-values. Let's go back to p equals 0.02. In this case, we reject the null and hope that we guessed right. But what does the p-value technically mean? It means that over in population land, if the null was true, we would only have had a 2% chance of getting the results we observed on Sample Island, or something more extreme, under the null hypothesis. It does not mean that there is a 2% chance that the null hypothesis was true, because we can never check that and we will never know. And it does not mean that there is a 2% chance that the results were due to chance. These are common misconceptions that we will address in other videos. Thank you.